Do you know the cost of a semiconductor fab facility is as expensive as an aircraft carrier? And this does not include any equipment cost yet. Why the insane cost? This lecture from a chip industry insider will explain to you why.
We're going to talk about silicon factories, the clean rooms where semiconductor chips are made. Especially, we're going to explain why the factories are so expensive and how expensive they are. In the previous sections, we talked about semiconductors and an overview of chips. We discussed the concept of dies and packages. So let's look at modern facilities and cost. The semiconductor processing facility has to be extremely clean because any kind of particles floating in the air, if they land on the silicon, they can bury many transistors. And out of a billion transistors, if a single transistor is not working, then that entire chip is not working. So you can see the importance of keeping the air very clean. The way to keep air very clean is to circulate the air and use a filter to trap the particles. So modern cleanroom facilities basically only occupy one floor in a building. There's air circulators and there are facilities to provide gas and chemicals and so on. It's very expensive. If you think of a very clean space that is hundreds of thousands of square feet in size, air conditioned, humidity controlled, and particle control. It's very expensive. And when you have to run many wafers per month, then you not only have to have one equipment, but you have many, many copies of the same equipment. So a modern clean room, in this case, a picture of a section of a clean room, you can see the same equipment forming a big row and arrays. This is not a special effect in a movie theater. And this space has to be built out and very, very expensive. This is inside of a 100K wafer production per year for a TSMC 3 nanometer nodes, and many equipment of the same type, forming a giant army of processing. For high volume products, you typically need to run 1 to 2 million wafers per quarter. Why? For example, if we look at Apple iPhone, the Apple iPhone typically have about 70 million units per quarter. So that means your number of wafers have to at least support this kind of production. And we're talking about several millions of wafers per quarter. In a modern semiconductor cleanroom, you not only have the facility cost, but you have the equipment cost. As you can see, the equipment cost actually dwarfs the facilities cost. The facility is already very expensive, but the equipment, the army of equipment of every kind, lithography, deposition, etching, actually is way more than just the facility alone. This figure shows the cost of semiconductor fabs in 2024 dollars from 1960 all the way to 2024, 2025. And it used to be $10-20 million in the 70s, and now it can be as much as 10 billion, $20 billion for TSMC and Samsung. This is Samsung in Texas, TSMC Fab 18, TSMC Fab 15. It's tremendous amount of cost. Here are pictures just to give you a visual presentation of how large the facility is, and they occupy large amount of ground, have a lot of expensive equipment, have pipelines for wafers, and everything is spells money. But ultimately, if you're successful and you can make wafers, make devices with high yield, then you have positive profit, and you print a lot of money this way. Today, Apple, Nvidia, they all make devices in TSMC. So TSMC's 2 nanometer node in 2025 represent the highest level of commercial achievement, and is expected to be first adapted by Apple for the iPhone 18. So only Apple, which is a volume, can actually use something so expensive. And the A20 series processor being fabricated using the advanced technology. You can see that not only are the integration density increasing, but the size of the die is also increasing. NVIDIA is a heavy user of TSMC. NVIDIA's chip, the newest, for example, Blackwell AI chips, are priced between 30,000 and 40,000 per chip. And they are quite expensive, and they cost a lot of money to make, and they sell for a lot of money. This is a healthy ecosystem where the demand and suppliers are all happily converging to make good technology happen. It's a competition, it's a race of technology development and innovation.